delightful. Everybody's either here and or accounted for. Even he is accounted for. He's going to be joining us virtually, so you can say nasty things to him, and he can't really get back to you. Which I'm all for. And we have, I mean, I haven't seen some of you people in a while. Although I enjoy seeing you. Oh God, I'm awful. Well, you know what Wednesday is? Opportunities knocking. It's okay. Just wanted to let everybody know. And so, and as we agreed on mutually, Friday is a non-combatant day. I will be departing here as soon as I give my micro exams. And see you later. Adios. See you guys after the break. No, no. Babysitting our great grandson on for St. Patrick's Day is the highlight film. And there's an off chance I might go visit my son, daughter-in-law, and the grandkids that weekend, but not sure. Let's see. We'll have to see what the future brings. Never like to plan too far in advance. And on that note, let's get started. Hey, we are at. Remember, this is kind of where we left off with antigens. We're going to get into really what antibodies do. This will complete the humoral immune system. Remember, this is stuff. It's not inside a cell. It can be on a cell, but it can't be inside the cell. And as we'll learn when we start to look more specifically at the mechanism for the production of antibodies, the specifics of it, which will come in the third and last PowerPoint of this relatively complicated unit. So I'm sure we will not get to it until there's a lot going on with this. It's a heavy-duty unit, I think. So again, something that can provoke an antigenic response. Okay, so we're looking at, and typically these molecules are unusual. When they say large and complex, I mean a bacterial toxin, a virus doing some damage is going to alter things significantly, and those are going to be large and complex molecules. Even though you would consider them an entity, the molecules themselves are comparatively complex. Again, they're either whole as stated, but particularly in the realm of allergies, we think of haptens, half antigen, the derivation of that, and they become complete when they bond with an existing protein in the individual. And so, and again, antigens now used to be inherently, by the definition, foreign, but now we have self and non-self antigens. So, and the whole idea of the determinant is that specific portion to which the body's response is geared to. That's the specificity. It's particularly about those determinants. They're going to form the framework of what this circulating chemical we call an antibody, or the circulating cell we call a cytotoxic T cell, what it attaches to, and what it basically, how the damage or how the control is exerted, either immobilizing them, destroying them, a variety of things that we'll look at a little bit today. So again, when they're complete, they have the ability to stimulate your immune system, specific lymphocytes, and the ability to react with those and release antibodies, etc., etc. All of these things are part of it. You can see they're not necessarily enormous molecules. Proteins would be, but polysaccharides, lipids, nucleic acids, a lot of things classify as that are there. The haptens, too small to be recognized, tiny, smaller peptides, isolated nucleotides, even some hormonal elements. And so, but the combination of the protein and the hapten completes it, and now it too becomes antigenic in nature. And the whole idea is that the immunological system is going to mount an attack that is in some way, shape, or form going to cause some impact. I mean, harmful is a term, particularly with allergies, when you want to think, I mean, you can construe anything as harmful, whether you just break out in a rash, whether you're just coughing or sneezing. It's something that is undesirable and would be considered adverse. All of these things are part of it that are there. It's very interesting, and there's a lot of science behind this. So the determinant, another term that we often see is called epitope, E-P-I-T-O-P-E. That's part of it. that effectively is going to bond to it. And indeed, the antibodies and lymphocytes are tailored to it. Okay. And typically there's more than one. So it may not necessarily be just one specific lymphocytic population. Okay. Different kinds of antibodies depending on what they are. This is interesting if you're going in or you're curious about materials, what makes things not have a great deal of immunogenicity. So large, chemically simple polymers. That's the beauty of polymers. They're just simple, massive numbers of a simple repeat that are there. So when we see things that are polyethylene for years, stainless steel, okay, these are materials that have a very low index of antigenicity. For forever, stainless steel has been being used in implanted materials for orthopedic purposes. Plates, screws, wires, all sorts of devices that are used for fractures. I have a lot of experience with those. When we're implanting biological materials vis-a-vis, and obviously my area of expertise is more on orthopedic implants, typically you're using a lot of low reactive agents, and polymers are one of them. Typically an artificial joint has, in the old days, and the technology is always evolving and changing, they would have a plastic component and a metal component. The difference with the two plastics coming together very often will release little shards, tiny, tiny pieces of material that can be problematic. And they found it was less likely, and this is just contextual for you. I really am interested in this kind of science, or I was when I was in practice. So that's why they typically combine a metal and a plastic. You'll see a hip, or you'll see a quote unquote plastic component and some kind of metal component. As it has evolved, there's a whole lot of material science. Some of my colleagues were all into that. They went all over the world to look what metal scientists were doing. It's really a very fascinating field. So, interesting. So, for instance, when we sew things up, I did forever. I used, years ago, we used silk, which you could react to, being effectively a plant product that you could be allergic to. And then we switched over basically to a plastic. And rather than use braided, we used monofilament nylon. Braided nylon could be more irritating, more, and we use monofilament nylon, monofilament stainless steel, those kinds of things that were used pretty extensively. And we used different sutures that were absorbable. They were effectively polymers that were, for lack of a better term, interiorly, you had the enzymes to biodegrade them and get rid of them. So they're internal absorbable sutures. Really interesting stuff. See, I actually did this stuff. I know you're looking at me and go, somebody making all these bad jokes. Why would you let anybody come at you with a knife? But yes, there was a time when I could still, and they're still pretty damn steady. And so that's what they mean. It's all about the shape. And the shape is predicated by typically the small carbohydrate units. They're typically glycoproteins, not unlike the same kind of things that we saw in the ABO blood typing. So we have self antigens located on the surface that are not antigenic to self, but may be antigenic to others in transfusions or grafts. That's the whole idea. Our immune system, pretty much in the first 6 months, is when a lot of this happens, just becomes acquainted with self. In the meantime, your immune system is being you're basically, your immune system is your mom's immune system. Whatever mom's antibodies, what we call passive. We'll talk about this in this chapter. Passive acquired immunity comes from mom at birth, and it allows your immune system to become acquainted with what you want. And it becomes acquainted with these self antigens or self markers. And so then we give them the term MHC for major histo tissue compatibility complexes. They're very unique. Okay. They hold pieces of self antigen or conceivably of foreign antigens. And again, as you can see, recognize only antigens that are presented on MHC proteins. We're going to get into, after the break, MHC1s and MHC2s. I mean, and there's a certain degree of complexity with this. And that's what I mean. When something, something effectively, the short course, when something alters a cell, the MHC1 markers are altered. So you will see that going forward. So the adaptive immune system, these are the kinds of cells. We have B cells, what we're going to be talking about first. T cells for cellular immunity, B cells, think of the big B for antibodies, okay? And really the big B also comes from bone marrow. These cells originate in the bone marrow, but become, there's specific terminology, but they become mature enough to be able to function in the bone marrow, hence B, and in the thymus is where the maturation process is completed for T cells, hence the monikers B and T cells. That's important. Antigen presenting cells, okay, they're those wonderful cells that are constantly sampling and available in certain organs where we have to do a lot of processing. They're in your skin, they're in your liver, and they're at a variety of areas in your gut. And what they are doing is a constant process of really wherever we come, we encounter the outside world, whether it's along a lining tissue, whether it's in the skin, and certainly if it evades that and gets into the bloodstream from some consumable, now the liver's got to handle all of that. And they play an important role when we look at the really complex chapter. The third PowerPoint contains all of those types of things. These presentations play a pivotal role in activating your immune system. It's all together. So these antigen presenting cells are really important. Effectively, what they do is they take definitely not my fragrance at all. I could get in trouble with this if I spritz myself. My wife's going to wonder. Basically, the antigen presenting cell grabs it, swallows it, and it presents the little tip. That's the antigenic determinant. So it's processing it, and depending on which MHC the tip protrudes from, it will make the determination as to whether this was a cell that was somehow become altered, or whether this is a free floater in the bloodstream or just sitting on some cells manufactured. I didn't know Ariana Grande had a line of cosmetics. There was one downstairs in the room below us, still there. It was like a lipstick, and it wasn't my shade, so I didn't take it. A little blush is good, though. Too full. I'm on a different planet. Somebody help me. Lymphocytes develop and mature, and so here it is. They're born in the bone marrow. That's really where they are. Maturation occurs whichever line it is, thymus or the bone marrow, and then perhaps the most common location are lymph nodes, and they will encounter an antigen. For argument's sake, let's call it a foreign antigen, and at that point, it will activate the process that we'll get into in some length. There's a lot of complexity to it. So the lymphocytes are educated. This is where terminology comes from. 2 to 3 days in those primary organs, bone marrow and thymus. And really, this is the important thing. Definitions are important in this, and the terminology is important. Not so much, I'll try to make my questions less like that, but depending on where you're going, sometimes if there's more tests, you got to watch out for terminology in this. So being immunocompetent means it's able to recognize a specific antigen. Okay, they only display one unique antigen receptors on their surface when they mature. That's the specificity. So if this invader's got 3 different foreign antigens, there'll be 3 different cells and or cell lines or antibodies, depending for it to respond to. And self-tolerance, they don't respond. They're unresponsive to your self-antigens. They don't hurt you in that way. So an immune system's out of whack, and this is where we talk about autoimmune diseases, when you're making stuff that's attacking your own tissue. I mean, there's inherently an error in this. And that's part of, and maybe the greatest foundation is autoimmune diseases, is for attacking healthy tissue or certain infections mimicking the signature of healthy tissues. Again, the old-fashioned, good old-fashioned strep throat, streptococcus. Most of its problems is from your immune system, and often it will mimic lining cells in the heart and in joints. That's what rheumatic fever is all about. So they begin to show it to you as its development, maturation, and activation. It really doesn't matter which one we look at. And then it seeds. In other words, once they have gained this degree of immunocompetence, the term we give them then is naive. They have not been exposed to a foreign antigen. So naivete, who we are with regard to certain things. It's like hey, I've never seen anything like this before. So they're not yet exposed. They're naive. That's the terminology. So, and they're exported from wherever they develop, and they colonize the secondary ones, lymph nodes, spleen, even the liver, and because those are the places they're more likely to encounter. Anything that we bring in, whether it goes into the bloodstream by way of the digestive tract or it goes through the lymph by way of almost every other type of channel, are going to be sifted through. Remember, we did the anatomy. For those that were, most of us were here in AP1. Effectively, it's a system where we have multiple inputs and limited outputs, and it's almost like filtering through a rather complex series of passageways where it will encounter a number of different lymphocytes ready to interact with it. So it's unlikely to get through one of those very easily without having some type of response. And so that's where it's placed. It seeds those particular organs, and then it's activated. Its first encounter triggers further development, and it differentiates depending on what it is. We call it clonal selection. It's going to clone specifically to basically take care of that specific antigen. That's where the specificity comes from. And then, assuming everything is in order, it will differentiate into that cell moving forward. So once it's selected, once it's activated, it forms basically a series of clones, an army of exact copies of itself. I mean, they use the term cloned. I would guess it's very, very similar to mitosis, but it's because of the specificity and the system. Cloning is very specific to the immune system. And they probably took I'm sure Star Wars in the original took the terminology from that. Clone Wars and all that good stuff. Never watched Star Wars. The line, when that came out in '77, was around the theater. And we also, can you imagine standing up with a standing ovation in a movie theater, the whole theater packed? We did that for 2 movies in successive years. One called Rocky, '76, and then the original Star Wars in '77. Oh my God. My buddy, we went to the same theater because it always got the first run stuff. Right near the Tacony-Palmyra Bridge on the Jersey side going into Philadelphia. Yes, remember it well. And so what happens, most of them become the effector cells. They're going to clone into other cells or clone into cells that generate antibodies. And of course, this is immunological memory. And so this is really significant. Both lines, whether it's a B line or T line, will have immunological memory. And the beauty of that is, I don't know, whatever analogy works for you. All of a sudden now you pre-programmed your hard drive. You don't have to go through loading it, making sure you have all the access codes right. Bang, it can start to make antibodies or make more cells right away. That's what your immunizations are supposed to do. Theoretically, facilitate or enable this process and do so without harming. I mean, that's optimal for all of those. They don't all do it, but that's, there's always potentially a downside, et cetera, and all of that. So Genes, not antigens, determine which foreign substances the immune system will recognize. So, and so there's a genetic basis to all of this. So acquired genetic knowledge of microbes plays a role. Okay. 25,000 different genes code up to 1 billion different types of lymphocyte antigen receptors. So there's a whole lot of diversity in all of these antigens without getting too crazy about that. T cells mature in the thymus. I don't really do this. The whole idea, it's tougher to be a T cell than it is to become a Navy SEAL. Only about 20% of the people who start over in Coronado Beach are able to become SEALs, and they're all ridiculously strong, tough guys. Only 2% of lymphocytes make the grade, and they're kicked out by these selection processes. You don't have to remember which is positive or which is negative. So positive selects T cells that are capable of recognizing self. So as long as they know what's self and what's not, otherwise apoptosis. Negative also prompts apoptosis of T cells that bind to self antigens. So they delete the clone or clonal deletion. So that, I mean, one, they have to be able to recognize self. Two, they have to not bind to self. So it's a very significant process that goes on. I mean, unfortunately, some autoimmune diseases, the T cells get out of hand, and it's big, big trouble. And they're just giving you an idea of how this is. Here you can see the antigen presenting cell, just like it does presenting that effectively the antigenic portion, the determinant, the epitope. Here it is with the T cell receiving it and recognizing it. So they're talking about positive and negative selections that are there. So the APCs are antigen presenting cells, dendritic cells, a variety of macrophages, and even B cells themselves. So even other lymphocytes can play that role. You'll see those play a pivotal role, particularly in T cell activation. Okay. It's a wonderful system that helps one another. Your immune system is frankly your best friend. Whatever you can do to immune health, I will tell you what I have read many times. It may seem trivial, and you're young folks, you probably do it anyway. But as you get older, basically doing 30 minutes of moderate to vigorous physical activity every day, it's fine. 6 out of 7 days, you're effectively keeping your immune system in tune. Effectively, think of it, you're increasing the circulation. You're basically pulling out from the bone marrow forms that have been born in the bone marrow, beginning to develop, blood going to the thymus, more of them getting there. All of that stuff's going on. It's use it or lose it, that kind of a system. And I'm a firm believer that in everything. It's just too easy. So there's really a lot of hard evidence to support that. And when I say moderate, I mean just walking around campus is probably enough for you folks. Okay, as you get older, it needs to be a little bit more tuned about that. So right now, I'm back at the gym on a regular basis. I got to be on I have received an order from the Almighty, my wife. Again, with the appropriate response to her. Yes, dear. So dendritic cells everywhere. Connective tissues, epidermis, sentinels, what they do, grab onto pathogens or other things, and they present them to the various kinds of cells in the lymph node. Okay, they're the big players. Key link between these. You can see all these tentacle-like projections. Dendritic, it's like a dendrite of a nerve. All those multiple receptors that are there. That's sort of like the trees that are just starting, that are empty and starting to fill in a little bit. Thank you. Please. We're almost done. Like 70 degrees outside. Oh, yeah. Cleaning off the deck. We were having a good time. We finally took down the Christmas tree.
It's a Christmas tree.
Oh, 2.5 months. But I like that. Yeah, my mother-in-law, she died last February, 98 and a half years old. She had several of them. They were all decorated in Steelers, Pirates, and Notre Dame. She had a very distinctive, her house was one of those houses everywhere. There was stuff everywhere. It's almost like you go to the campground at Christmas in July, except it was everywhere. Yunnan campground stairs. Christmas in July is a big thing. You know, my wife's face paint had been very bad the last couple. Now it's starting to get better. She said, "I'm not taking this tree down until it starts to improve." So we can hope it stays continuing to improve. So the macrophages are all over the place, okay, in connective tissue. Again, antigens are presented, activated macrophage, then basically in turn becomes activated by this line, and also the inflammatory response. So they play a pivotal role. And even B cells, okay, present antigens to helper T cells to assist their own activation. You're going to start to see the role after break of the important, extraordinarily important role of the helper T cell. Its name is perfect for that. Just a nice little summary chart, no problem there. B cells provoke the humoral immune response. Okay, antibody specific for that particular antigen are then produced. That's the one we're going to deal with first. B cells activate, antigens bind to them. Okay, and as you can see, what happens is triggers receptor-mediated endocytosis of cross-linked antigen receptor complexes, leading to proliferation, blah, 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 blah. So effectively, once these B cells become activated by things like antigen-presenting cells or macrophages, effectively it becomes clonal selection. And it's a little bit different. These two different types that we'll take a look at. Most of them, the effector arm of the B cell line, again, and if you want to think B, not only for bone marrow, think antibody with a B. Plasma cells are antibody generating factors. They are the effector arm. The antibodies are the effector molecules. But plasma cells go crazy, as you will see numerically. They secrete specific antibodies. Look at the rate. Once they're activated, 2,000 molecules per second for 4 to 5 days. I mean, after that, you die too. Think of how much production goes on. It is immense. They enlarge, and effectively they're dedicated to all this. Do you remember looking at polyribosomes? Polysomes? Is that ringing a bell? Okay, so you had multiple ribosomes attached to the strand. Think of each one of those producing antibodies, antibodies, antibodies. A cell that's enlarged has a very highly developed endoplasmic reticulum structure and those things. They circulate all over and mark them for destruction. They don't understand antibodies themselves do not destroy, whether it's microorganisms. They don't necessarily destroy materials that they're coming in contact with that are causing it. They effectively bind to them, and they do a variety of things that enable, and effectively they mark them or tag them, neutralize them. You'll see the different ways soon. So here it is, the primary encounter with the antigen. Okay, so the antigen binds to a receptor on these B lymphocytes. They will start to clone. The vast majority will clone into the effector or B cells, which will morph. And as you can see with that little red, that's really the increased amount of endoplasmic reticulum. And voila, out come antibodies. That characteristic Y or T shape. That's by certainly no mean rigid, but it's a very good way of understanding it. And then you have a certain amount of memory cells, and the beauty of them is the immunological memory, for the most part, is very long-lived. you don't, if you think of it in the context that many of you have had it, you occasionally need booster shots to re-trigger that. We all do for things like tetanus or pertussis or diphtheria, which is a triple, it's a trivalent immunization. So when you get a tetanus shot, you're getting two others. So we lose that over time. Generally, from when you have it in childhood, you may have had ones that you had to get here to go into high school or go into college. I don't know what the criteria are, things like that. They're different for everybody, and they've changed over the years. It's not my job to figure those out. Okay, but understand that some of them have a lifespan, some do not. In general, if you have the disease, your immunological memory is longer. So I had all of those things. The only one of those, what we call the usual childhood diseases, were four: chickenpox, measles, mumps, German measles, or rubella. Your MMR covers those three: measles, mumps, and rubella. And then you have a vaccination for chickenpox, which is known as varicella. I didn't have the mumps. I got the mumps immunization when I was an adult, when we were first married and we were going to have kids. So, and that was done for a reason. And even then, the doctor said, hey, 3 months, take all precautions. Okay. But I've never had to get a booster for measles, which I had, chickenpox, which I had, German measles, which I had. None. So the clone cells that do not become plasma cells become the memory cells. And the beauty of that is the response is much faster. And that's the beauty of what happens if you've been reading the newspaper. Measles is making a major league comeback. They just had a giant outbreak in Northern California, at least 100 cases. It's the most contagious disease we know. There's a lot of people who have become very vaccine lax for a variety of reasons. That's not what I would be lax about. It is not innocent. Periodically, somebody dies from the measles. It's pretty rare in this country. It's very common in other countries. Third largest killer in sub-Saharan Africa, after malaria, AIDS, then measles. So don't think, no, it's just the measles. Nobody died from that bullshit. Sorry about that. I'm trying to make a point. So here you are. And this is the beauty of it. Your primary response. Let's say you got a staph infection. Let's say you got strep throat. Why do I have to have antibiotics? It takes a little while. And understand why you have to continue to do it for streptococcal infections. There's enough variation that in those entities that there often is not a significant degree of immunological memory. Cells proliferate. Okay, the lag period is 3 to 6 days for your immune system to ramp up. Okay, and then peak levels are reached in 10 days. How long do we typically get antibodies prescribed to us? 10 days. 7 to 10 days. If you're thinking about a Z-Pack, okay, well, it's only 5 days. The reality is the way that that medication was developed by Pfizer is a time release. So you're building up blood levels that will be existent for after about the second day. You have blood levels that will last for 10 days when you finish taking that last capsule on the 5th day. It's not stronger. It's all about the science behind it. What it did was to make it less likely to upset your stomach, which is a real benefit. It was a little reward Pfizer got. Another one of these what do they call billion-dollar drugs. So that's the secondary response. So the next time you're exposed to that, like, think of that's why you get the immunization. The memory cells take over, and it doesn't take 3 to 6 days. It takes a couple of hours. You don't even know it. You might have all of a sudden thought, I feel like something's coming on, and the next thing you know, not there. That's your immune system to thank. So peak in 2 to 3 days at much higher levels, bind better, remain high for long periods of time. That's the beauty of it. And it's a great chart. And here, if you have, and the first time you have that infection, okay, the second exposure, look at the timeline about, we're dealing with them 3 weeks after the exposure was here. So 4 weeks after the exposure, boom. Immense. And look at the slope. It didn't take days. It's almost instantaneously, hours. Now, the next time you are exposed to a new agent, okay, you got to go through the whole process again. So that's to me, that's a really good graphic display of that. And it really underscores why we take antibiotics and why they're necessary depending on the situation you're in. Obviously, there's a lot of criteria when you're dealing with antibiosis. So this is where we get to the little nuggets about how we categorize different kinds of immunity. These are important. So active humoral immunity. Active means me. I didn't have to get an MMR because I had the M. I had the R. The M in the middle I didn't have. So active immunity occurs when B cells encounter antigens and produce specific antibodies. So I had naturally acquired immunity to the bacteria, or in this case of measles and rubella and chickenpox, those viral infections. Did I tell you about how we all got measles and chickenpox? I got you this time, Ruth. Love you. At the end of my first grade, which was 1957, started maybe 58. Yeah, I was 7 years old. My mom, all the moms, everybody in the neighborhood was the same. We all moved there. They all had kids. They were all the same age. It was one of those communities. Everybody left the city and went to the suburbs. We're all going to the circus. Yeah, Ringling Brothers Barnum and Bailey Circus was in the old Madison Square Garden. That was before the new one, which is about the oldest arena you can watch basketball or hockey. Is it? That was built in '67. We're going to go to the Automat, which is a very neat place that existed. You put coins in and you could pick what you wanted, take out the sandwich or the piece of pie or the bowl of soup. They put it back in. It was very clever. So it was like tailored to us wide-eyed kids. Take the bus, walk around, do all this fun stuff. Within a week of being there, nearly everybody in the neighborhood came down with either measles or chickenpox. And about 3 weeks later, we got the other one. Those were called, moms used to have measles and chickenpox parties. They wanted the kids to get over it. And right after school was a very good time. I know, child abuse. This is nothing new under the sun. Deliberately infecting your kids because the moms and dads, we all had it. They wanted to get rid of the headache. Gotcha. It's okay. I forgive you. You are not of that age because you had the immunizations. So I had naturally, but under suspicious circumstances, acquired immunity. Artificial, what do you have? Vaccine. Okay, provide the antigenic determinants that are immunogenic and reactive, but you don't. What we've done is we've called attenuation. Attenuated. We have treated whatever the part that's going to make you sick in such a way that it doesn't make you sick, in this case, let's say the virus, yet retains its antigenicity and reactivity. You don't get sick, but your immune system still responds. That's what immunizations do appropriately. They are not innocent. I say it again and again. The only time you use an immunization if it's going to have more benefit than downside. They've tried cold and people don't die from the cold. Why people die from immunizations? There are a lot of complications. That's people don't understand that. And I mean, you're getting my spin. I acknowledge this fully. We are over vaccinated every time. Just sick and tired of getting these COVID boosters. And I know, and the fact that they made students when they returned to the campus here, if they did return to your school when you were in high school to have the vaccine, that it should be their choice for that. Absolutely wrong. 97% of our faculty were vaccinated. I am one of the 3%. And what am I now? In the top 5 of oldest?
Mom had to get it. She was in the military.
Right.
After that, she develop lupus and seizures.
Yeah, I mean, there's just, I had a wonderful guy who was here, was like you guys, bio majors. When I'm doing this talk with him, he goes, yeah, I got myocarditis. I was in the hospital for a week. Okay. Yeah, military, it's do that. I've got a son like that.
Yeah. Well, she said even if our school was like making it mandatory, like after everything happened with her, she's like, I don't even care if you guys even go to school. She's like,
Yeah, I know. Because I mean, if you experience a complication, I understand liabilities. I understand legalities. A lot of what happens, whether it's in this school or the workplace, has a lot to do with we're governed by our insurance company. Okay, a lot of what we have to do, we have to clear it with the insurance company before we can do it. It's the nature of the beast today. Everybody's scared about getting sued. So that's the active immunity. So whether it's natural or artificial, so too it is there for passive, ready-made antibodies. So if you are naturally acquired, that's mom. Okay, B cells are not challenged. There's no memory. It ends because the antibodies have a lifespan. Antibodies delivered to the fetus via the placenta or the infant, coming from mom, one way or the other. That's really holding you together, assuming that you don't have to have it. There may be selective cases where you have to have some type of bolster. Artificially acquired is in the old days when we had the very famous Chi-Chi's outbreak of hepatitis A, the treatment was gamma globulin. That was sort of a general bolus amount of antibodies. We have an immunization for that. There's more specific treatment. Okay, and so for instance, if you were bitten by a snake, they give you antitoxin. That is an antibody specific. I don't know how much of a call they have for it down here. A really good friend of mine, many years ago. He was a lead pharmacist for, like, in charge of like six pharmacies, six hospitals, and a hospital system was his division. I mean, I went into his bar fridge to get. I really don't drink, just to get like a Coke or a Pepsi. And just vials of poly, polyvalent snake venom. And I said, really? He goes, no, I have to bring those to the hospital all the time. This was in Texas. And so this just summarizes all of that for you. The antibodies are called immunoglobulins. That's the gamma globulin portion. I have a little bit more to cover. Bind specifically, okay, one of five immunoglobulin classes. You probably studied this in cell molec, or if you studied antibodies, biochem. So for those that had that, it has that distinct shape. We have heavy and light chains, two heavy, two light chains, and the variable where you have a constant region and a variable region. So I'll show it to you, it's easier. The constant region tells you what category. So the constant region determines the antibody class. Okay? They consider that the effector region because it's really what it does. Types of cells or chemicals that the antibody can bind, what category it's in. And you can see they work by activating complement, some circulate in the blood, some are in secretions. It's all about that constant region. This is the constant region. Even though and you have the heavy chains are longer. Typically, they're held together by what kind of bonds? Bonds. What kind of bonds? For structural stability? Disulfide bonds. Excellent. They're held together by bond, disulfide bond. That Here they are being held together. And this portion is the part where they're fashioned specifically to the determinant or epitope. That's why they are the variable region. And so, I mean, it's a good schematic to take a look at it. The five categories, I always remember however it works for you, I use MADGE because it's MADGE. So IgM is the first one on the scene. When we want to see the progress of an infection, we can titrate, like you do in the lab. We can analyze whether they're IgMs or IgGs. If you have an abundance of IgM, you're early in the course of the infection. If you have an abundance of IgGs, you're later in the infection. If you're still seeing IgMs later in the infection, that's a problem. You shouldn't have the initial responders there. That means you're not fighting it very efficiently. See, this is the kind of stuff which is important. So it's the largest, the only one that's a pentamer. And that's the interesting thing. And you'll see when we get to how it agglutinates, which we won't do today, all the things it does. IgA, classic in secretions, whether it's saliva, whether it's mucus, all of those things. That's one of the things that sends it to that area. So body secretion, any type of body fluids, anogenital area fluids, all that type of stuff. And you can see the look and read through this. So you can imagine when this latches onto multiple things, how it can agglutinate, makes lumps. This one is a dimer. These principally are all monomers. Okay, IgD, we think this plays the role on the B cells that acts as a receptor. For the longest time, it was not really clear what it did. IgG, the big player, the vast majorities are Ig for immunoglobulin G, okay, secondary and late primary responses. This is the one that crosses the placental barrier. This is the one that you're getting from mom, okay, and IgE, very significant for allergic responses, very significant for parasitic responses. So we're going to see this attached to mast cells, which are really basophils that have changed, and eosinophils. And it's all about histamine release. And they give you a nice little summary there. And so, as you can see, they can switch as necessary. They retain the same specificity, IgM primary for plasma cell switch for IgG for secondary. Almost all secondaries are IgE. So there's other switches that can occur. We'll stop it here. We'll pick it up from that. Undoubtedly, we'll pick it up after the start of the year. Thank you very much. It's been a joy having